Hi everyone, this is Rakshita BK, studying at Sri Venkateshwara College of Engineering, the Department of Electronics and Communication. Today I am going to discuss about the data flow diagram of ARM processor. Introduction. The ARM microcontroller stands for Advanced RISC Machine. It is one of the extensive and most licensed processor cores in the world. The first ARM processor was developed in the year 1978 by Cambridge University, and the first ARM RISC processor was produced by the Akron Group of Computers in the year 1985. This processor are specially used in portable devices like digital cameras, mobile phones, home networking modules, and wireless communication technologies and other embedded systems due to these benefits such as low power consumptions, reasonable performance, etc. Now we'll see the ARM architecture. The ARM architecture processor is an advanced reduced instruction set computer RISC machine, and it's a 32-bit reduced instruction set computer. Akron Computer Organization in 1987, this ARM is a family of microcontroller developed by markers like ST, Microelectronics, Motorola, and so on. The ARM architecture comes with totally different versions like ARM v1, ARM v2, etc. And each one has its own advantage and disadvantage. Now we'll see, this is a block diagram of ARM block diagram. The first component present in ARM block diagram are arithmetic logic unit. Arithmetic logic unit as to 32 bits inputs. The primary comes from the register files, whereas the other comes from the shifter. Status registers flags modified by the arithmetic logic unit outputs. The V bit output goes to the V flag as well as the count goes to the C flag, whereas the foremost significant bit really represents the S flag. The ALU output operations is done by NORAD to get the Z flag. The ALU has a 4-bit function bus that permits up to 16 opcode to be implemented. Boot multiplier factor. The multiplier factor has the 32-bit inputs and the inputs written from the registers file. The multiplier output is barely 32 least significant bits of the Mercatus. The entity representations of the multiplier factor is shown in the above block diagram. The multiplication starts whenever a beginning 4 input goes active. Fine of the output goes high when finishing. Booth algorithm. Booth algorithm is not worth the multiplication algorithm rule for 2's complement numbers. This treats positive and negative number uniformly. Moreover, the runs of zeros and ones within the multiplier factor are skipped over without any addition or subtraction being performed, thereby creating possible quicker multiplication. The figure shows the simulations results for the multiplier test bench. It clear that the multiplication finishes only in 16 clock cycle. Parallel shifter. The parallel shifter features are 32-bit input to be shifted. These input is coming back from the registers files, or it might be immediate data. The shifter has different control inputs coming back from the instruction registers. The shift field within the instruction controls the operations of the parallel shifter. This field indicates the kind of shift to be performed: logical left or right, arithmetic right or rotate right. The quantity by which the registers out to the shifted is contained in an immediate field within the instructions, or it might be lower 6 bits of a registers within the register file. Next, control unit. For any microprocessor, control unit is the heart of the whole processor, and it is responsible for the system operation. So, the control unit designs is the most important part within the whole design. The control unit is sometimes a pure combinational circuit design. Here, the control unit is implemented by easy state machine. Processor timing is additionally included within the control unit. Signals from the control unit are connected to each component within the processor to survive its operation. Next, we will see the ARM microcontroller register modes. The ARM microcontroller is a load store reducing instruction set computer architecture, means the core cannot directly operate with the memory. The data operations must be done by the registers and the information is stored in the memory by an address. The ARM Cortex-M3 consists of 37 register sets, wherein 31 are general purpose registers and 6 are status register. The ARM uses 7 processing modes to run your task, that is user mode, FIQ mode, IRQ mode, SVC mode, and undefined mode, abort mode, monitor mode. Next we'll see the user mode. The user mode is a normal mode which has the least number of registers, but it doesn't have SPSR and has limited access to the CPSR, FIQ and IRQ. The FIQ and IRQ are the two interrupt caused modes of the CPU. The FIQ is processing interrupt and IRQ is a standard interrupt. The FIQ mode has additional 5 banked register to provide more flexibility and high performance when critical interrupts are handled. SVC mode. The supervisor's mode is a software interrupt mode of the processor to start up or reset. Undefined mode. The undefined mode traps when illegal instructions are executed. The ARM core consists of 32-bit data bus and faster data flow. Thumb mode. In thumb mode, 32-bit data is divided into 16-bit and increases the processing speed. Thumb 2 mode. In Thumb 2 mode, the instructions can be either 16-bit or 32-bit and it increases the performance of the ARM Cortex-M3 microcontroller. The ARM Cortex-M3 controller uses only Thumb 2 instruction and it increases the performance of the ARM Cortex of M3 controller. The ARM Cortex-M3 microcontrollers uses only Thumb 2 instructions. These are the instructions which we have shown in the registers, that is ARM processor registers. That is, one is user mode, FIQ and IRQ, SVC mode, undefined mode, thumb mode and thumb 2 mode. Thank you.